Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today, my name is Muhammad Aiman Hakimi bin Muhammad Burhan. I'm from Group 9 for ECE521. So today, I'm going to explain about my lab 3, which is this is the schematic diagram. So briefly about this project is about when we this is about the keypad. So when we press one in the keypad on the keypad. So the output is the LED, which is the LED 0 and LED 4 will turn on, which is have a two LED. Secondly, when we press 5, and then the two LED will on, which is the LED 2 and also the LED 6. Then when we press 8, when we press 9, three LED will be on, which is the LED 3, LED 5, and also the LED 7. But this is have a blinking, which is the delay is 0.5 second. And lastly, the keypad, when we press the three LED will on, which is the LED 1, LED 2, and LED 4, and blinking in the delay 5 second. So I will briefly show you the explanation for the coding. So for the first line and to the 12th, for this part of the coding includes the STM32F4 library and declare functions prototype for system operation, such as a delay and keypad initializations and input. Then LED initializations and also the LED control. So the main functions is begins with the execution where a char variables key is declared to store input from the keypad, which is the input that we used to which is a 1, 5, 9, and D. Then the function keypad init and LED inits are called to initialize the GPIO pins for the keypad and LED, which is to ensure the system is ready to read the keypad input and also to control the LED accordingly. And this setup is prepare the microcontroller to perform further operations like reading keypads input and activating LED based on the specific logic implemented later in the coding. So for the line 7 to 36, uh, the main function where this in the system will continuously monitor the keypad input and also will control the LED accordingly. And this program enter an infinite while loop, which is the keypad gateway function will detect any present key, which is a 1, 5, 9, and also D. A statement, we use a switch statement to check the value of the key pressing, which is 1, will turn on the LED 0 and LED 4. When we press 5, turn on the LED 5, LED 2 and also LED 6. But when we press 9, the blinking LED 3, LED 5, and LED 7s, with a 0.5 second delay. And when we pressing the blinks LED 1, LED 2, and LED 4 with a 5-second delay. And this case ensure all LED are turned off. With the default is to ensure the all LED turn off when no valid key is present. And a small delay like 100 milliseconds is added to stabilize this loop and avoid rapid key detection or LED filtering. And which is this to ensure the structure efficiently combine input detection and also the LED control in a responsive system. Then for the line 88 and to the 49, this coding to as you can see, the coding to initialize the keypad GPIO-C and GPIO-B clock. We are modifying the RCC, we say the reset and clock control register. And then next, it's figure the pins PC0 to the PC3 as a output, which is to representing the row of the keypad by clearing and setting the appropriate bits in the mode register to set their modes. And then it's figure the pins PC4 to PC7 as a input, which is representing the columns of the keypad. We pulls up register by modifying PUPDR register. And so the setup is to ensure that row act as an output for scanning the keypad, while the column detect key present using pull up register, which is help to maintain a stable high input state and when no key is present. So next I will pass with my to my friends Ikhwan.
Thank you, Mohammed Aiman Hakimi. So before I go further about uh, the next line about my part, let me introduce about me. So my name is Muhammad Nur Ikwan bin Muhammad Nazaran, and you can just. All right. So for the line 51 to 69, as you can see in the picture, this code sets up the LEDs and the keypad for a microcontroller-based system. The LED, uh, we just have to initialize LEDs underscore initial function configures pins PB0 to PB7 as outputs by enabling the GPIOB clock and also adjusting the mode register. This also set the pins to high speed mode using the OSO speed register. This to ensure the LEDs can toggle quickly. Uh, Next, the keypad's get key function defines a 4 times 4 keypad layout using a character array, where each position corresponds to a specific key, like 1, 2, A, D, etc. So makes it easier to scan the keypad and match the input with the correct key. So by together, this function prepare the system to control LEDs and read keypad inputs seamlessly. Alright, so next for line 70 to 84, as you can see in the picture, uh, this code is part of a keypad scanning function that detects which key is pressed on a 4 times 4 metric keypad using GPIO pins. The outer for loop iterates through each of the four rows, setting one row to low at a time while keeping others high using ODR, otherwise known as Output Data Register of GPIO-C. For each active row, the inner for loop checks the four column inputs by reading the IDR input data register and verifying if any column line is low, indicating the function returns the corresponding key value from the predefined keys array based on the active row and column. If no key is pressed, the function will return zero. Uh, so next, line 87 to 100, this code defines this part define the LED control function, which controls the state of LEDs connected to GPIO-B based on two parameters, whether the LEDs should blink and the blink delay time. If the blink parameter, so for uh, our LED, if the blink parameter is true, the function enters a loop that runs 10 times, toggling the specified LEDs on and off at intervals determined by the blink delay parameter. Using the ODR output data register of GPIOB, the LEDs are on for half of the blink delay and off for the other half. creating a blinking effect. If blink is false, the LEDs are simply turned on for a duration of 500 millisecond. This to ensure they stay illuminated long enough to be visible. To be visible. And then the function allows both blinking and steady illumination modes for the LEDs. Next, I will pass to my friend, Ayman.
Okay, so the last line, which is the line 100 to 108. So this is the delay functions. So what is the function of the delay functions? Which is to create a delay by running a simple loop, which is it takes us an input millisecond, which is the number of millisecond is to wait. And inside the loop, the NOP instruction is called repeatedly, which does nothing but takes up time. And the number of iteration is based on the input milliseconds and multiplying it by the 4,000 roughly, given a delay of 1 millisecond, depending on the system clock speed. And it is a basic way to pause the program. And so it may not perfectly accurate depending on the actual clock frequency. So next, I will provide you a video about my project, which for a second. Okay, this is the output that we got after running the coding successfully, and this output that we got. So as you can see, I repeat again, when I press one, so LED 0 and also the LED 4 will turn on. And then secondly, when I turn the 5 in the keypad, so LED 2 and LED 6 will light on. Then I press 9. So I have blinking about the delay 0.5 second for the LED 3, LED 5, and also the LED 7. And then lastly, when I press the button, so the LED 1, 2, and 4 will blinking in the 5-second delay. So I think that's all from us. Thank you, and Assalamualaikum warahmatullahi wabarakatuh.